original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Elena Hyde, and I'm joined tonight by Satish and Paul. We are, in fact, broadcasting tonight live from the Alan I. Carswell Observatory, located at the somewhat cloudy York University in Toronto, Ontario, Canada. This is, in fact, Astronomy Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, and then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT if you're in another time zone. The York Universe production works in concert with our online public viewing program run by our observatory team. That's right, it's happening at the same time. It actually runs also between the hours of 9 to 10 p.m. local Toronto time. You can head on over to observatory.info.yorku.ca and follow the links to OPV for online public viewing, or you can head over to our YouTube channel direct and see them. That's York U Observatory on YouTube. They're probably broadcasting right now. This broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. If you have any questions or comments for our past shows or suggestions for future topics, please send us an email at observe@yorku.ca. As an extra note, you can always connect with us on Twitter or Instagram at the handle @York Observatory and Facebook at Alan I. Carswell Obs. All of our programs are free, but if you'd like to make a donation, you can see our website at observatory.info.yorku.ca. Well, welcome everyone to this first night back after the Halloween weekend. We have all kinds of great astronomy stuff coming up, but also all kinds of great astronomy stuff that has happened in the past. Paul and Satish, how are you both doing this evening?
Excellent indeed, Elena. Hard to believe that it is November. Wow. Halloween yesterday and November today. Oh, wow. So little of the year left.
I like the way you sounded, like pronounced November. Never thought of that. But I'm only looking at non-clear skies. Like I stare at the skies, and well, that's my story.
So it's cloudy, is what you're saying.
It's cloudy. It rains. Yeah.
I guess it's good. It's good for Halloween, but not necessarily for observing.
Well, Vancouver is renowned for being cloudy from July 1st to June 30th.
Absolutely. So, in fact, the funny thing is the summer this time was absolutely clear, but it lasted for a very short time. So that was my first summer in Vancouver, so I can't really comment on the reality of summer in Vancouver.
It's a shame. It's a beautiful city. The West Coast is spectacular, but the weather in terms of astronomical weather, it leaves much to be desired.
Yeah, so we've not been doing too much better here the last few weeks, but I'm hoping
that's true. It's true. Hey, you've got to learn patience if you want to be an astronomer. It's as simple as that.
Absolutely. Keep ourselves busy by, looking at what was happening in space and astronomy history.
Well, I can take you back about 21 years to November 2, 2000. Hard to believe that it's been over 21 years of continuous occupation of the International Space Station. Let's go back to day one. As I said, November 2, 2000 saw the docking of Expedition 1 to the International Space Station. The crew arrived aboard a Soyuz TM-31 spacecraft, and for the record, they left aboard a Space Shuttle Discovery the following March, but more about that in a moment. But they popped the hatches and went into the very nascent International Space Station. At that point in time, it consisted of 3 modules, Zarya, Zvezda, and Unity. It was pretty small. The 3 of them were cozy, what can I say? But nonetheless, that was the beginning of the continuous occupation of the International Space Station. Who were the intrepid crew of Soyuz TM-31? Well, none other than Commander William Shepard, obviously of NASA, and then the two Russian cosmonauts with him, Yuri Gudзенский and Sergei Krikalev. These three intrepid individuals basically powered up the entire three modules, although Unity couldn't be powered up continuously because the space station at that point in time did not have enough power. They could only power continuously Zvezda and Zarya. That means, of course, that the three got pretty chummy. Yeah, that wasn't a whole lot of room, but it was essential. This was the beginning of this long international collaboration where literally the systems were being brought online and learning to live continuously in space started. The three astronauts saw three differing space shuttle missions arrive. There were a number of Progress resupply missions too, but it was the space shuttle that was ferrying up stuff that would basically enhance and enlarge the International Space Station. The first vehicle, in fact, arrived was STS-97, and Mike Garneau was on board, just as a matter of interest. It is, after all, Astronomy Night in Canada. And the main cargo of STS-97 was the first set of solar panels, the voltaic solar cells that basically quadrupled the amount of power to the infant space station. And that allowed, of course, Unity to be brought online continuously. The final mission, not the final mission, but the final event of Expedition 1 was the bringing up of the Destiny module, which was the first of the purely dedicated science modules. This was a NASA module, but it was the first of multiple science modules that were going to be attached to the International Space Station. Needless to say, Expedition 1 was pivotal. We had to start somewhere, and it all started with a 140-day mission starting on November 2, 2000. And we've not looked back since. So, tip of the hat. Cheers to the Expedition 1 crew. And they also, by the way, started that rather interesting little, I can't quite think of the right word, but custom, I guess, is the best word. Every time a space shuttle arrived, they would ring a bell just like it was arriving at a 19th century train station. So this bell would ring and William Shepard would call out, space shuttle whatever, arriving, and it really was quite cute. Anyway, that's what I remember from William Shepard's time as the commander of Expedition 1. 21 years and counting for the International Space Station.
Wonderful. Yeah, you say ring a bell. I just keep thinking It's a Wonderful Life, but
well, that works too.
But yeah, no, it's a great. It really is amazing that it has been 21 years, and Expedition going up, and then Endeavour, which came up. Oh gosh, I don't remember when Endeavour was actually going up, but I remember thinking when I read about it that I couldn't remember if it was the space shuttle, the shuttle flight that happened first, or the Star Trek ship that got named first.
Oh,
because this is one of the things that happens if you get a lot of Star Trek and a lot of astronomy. You get things like Endeavour and, of course, I mean, obviously Enterprise, where the names appear multiple places. So you get good
Discovery. I mean,
Discovery,
right?
yes, Discovery, exactly. So it's always a little bit of a game of which one came first in this case.
Well, that's true. Well, of course, Endeavour came into existence after the loss of Challenger. So yes. Endeavour came into existence in the late 80s, but I can't remember when Endeavour of Star Trek fame actually materialized.
I want to say Next Generation, but I'll leave it to the fans to sort that one out.
Yeah, just don't know. Of course, that was the era of Next Generation, 86 to 93 or thereabouts. But yeah. Anyway, the International Space Station continues to thrive, which I'm really excited about. And
yes.
I get a little worried when we talk about decommissioning it. I'm hoping that, even if the various space agencies decide that it's becoming too expensive, I really do hope that they transition it over to the private sector so it can continue to be used. It's such a venerable vehicle. It's hard to imagine Earth orbit without the International Space Station.
Yeah, well, it took 21 years for it to get this awesome. I mean, as you say, when they first started off, it was such a tiny little cramped place. Now they're up there making like tacos with real jalapeno peppers
Yes, I saw that. That's
and
right.
drinking, espresso. And it's like, this actually sounds like a nice place to go now. I mean, we should keep it around, right?
It's a tourist destination. We've had tourists fly backwards and forwards. There's another group going up in early 2022.
Absolutely. And it is a wonderful facility. It's actually in, pretty good shape by all accounts.
By all
So,
accounts. I agree.
well, anyways, that's our sidebar for today.
Yes, exactly. If anybody wants to buy
So
Elena
when-
or Paul a ticket, please send for proceeds to ...
Observatory.
I wasn't going to say that.
No. All right, so let's go back and forward a little bit and dive into some more astronomy and history before we get too sidebarred. Satish, I think you had some birthday shout-outs.
Sure. As I actually am going to take us back quite a few centuries for November 1. So, we will talk about, I think the pronunciation should be Jan Brohek. He was a Polish polymath, or the not so good pronunciation would be Jan Brozek or Brozek. But anyways, so he was born in 1585. A polymath would of course be a mathematician, an astronomer, a physician, a poet, writer, musician, and he was also the rector of the Krakow Academy. Oh, that's an interesting name, and I think anyone can Google this. He was the most prominent Polish mathematician of the 17th century, hence also the mention here. He was working on the theory of numbers, particularly perfect numbers, the kind of things that I actually never want to get into. And he also worked in geometry. He also studied medicine, theology, and geodesy. Among the problems he addressed was why bees create hexagonal honeycombs. And he demonstrated that this is the most efficient way of using wax and storing honey. So, well, too many hats, but he was an astronomer as well. And for those of us who want a real bite of it, is because he contributed to a greater knowledge of Nicholas Copernicus' theories. And he was a very ardent supporter and probably an early prospective biographer. So that's one shout out for Jan Brohek. And for the same date and 3 centuries later, I'm sorry, we would also like to celebrate, in hindsight, of course, the birthday of Nancy Davis. Actually, her name also has a Jan in there somewhere. She is an astronaut, or she was an astronaut, and she's still alive, I think. She was born in 1953. She was an engineer who joined the NASA's Marshall Space Flight Center as an aerospace engineer. In 1986, she was named as team leader in the structural analysis division, and her team was responsible for the structural analysis of verification of the Hubble Space Telescope and the HST maintenance mission and the Advanced X-ray Astrophysics Facility. So we're talking about the real early days of everything in space research. She also is a veteran of 3 space flights, and Davis has over 673 hours in space. She flew as a mission specialist on STS-47, that was in 92, and then STS-60 in 94, and then STS-85 in 97. These are the missions which I think we don't talk too much about, but there have been too many of them. So, well, I think November 1 has been a great day in history for astronomers.
Absolutely. And I love that you include you go all the way back to the 1500s. I've been reading some old Canterbury Tales, and one thing you realize as you go back to very early times is not only is it very hard to read because all the words are substantially different, but in studying physics or physique, you get astronomy and physics and studies were all combined. And so your birthday shout out, your mathematician, astronomer, physician is actually a pretty popular combo back in the day. And it's, really nice to see that come back now. Is like, you wouldn't find that as often nowadays as you.
The amount of information in any of those disciplines is more than enough to overwhelm the standard professor, shall we say, to be able to specialize in physics, poetry, writing, astronomy, mathematics, and so on. That is unheard of today. But back 4 centuries ago, our knowledge was only just expanding into all those realms, and so in practice or in practicality, people could be pretty well the master of each of those domains simultaneously.
Well, and they weren't necessarily separate domains as well, because if you were doing
yes.
if you were doing treatment of patients, you're a doctor. There's a good chance you would be asked for some astronomical or astrological advice as well.
Yes,
so it was an important part of your medical career. But I think now I definitely leave the medical part of it off to someone else at the moment.
Somebody who really is a specialist in nothing but medicine, please.
Yes, exactly.
Exactly right. But Nancy Davis also had a very important role to play. I mean, not only did she fly 3 shuttle missions, and as you said, Shadish, there were 135 of them. We don't talk about every last one, but each had its own important niche. But her role with the Hubble Space Telescope needs to be underscored. There's a telescope that is now over 30 years old. So her team, putting together the structural complexities of the HST, obviously they did a good job.
I think she also contributed to the Chandra X-ray observatory later on.
Yes.
So she's been active. Yeah.
Certainly has. So tip of the hat to her.
Absolutely, and it is worth noting as well as these missions don't get call outs as often as they should. So thank you very much for including that. All right, so I'm going to have to unfortunately take us away from that particular area for the moment. I'm going to go, I don't know, forward in time? Yes, it's definitely forward. So I'm going to somewhat recent days. We're going to November 4th, 2003. Scientists observed the largest solar flare. So largest solar flare in recorded history, or so it was thought. And then they checked again, and it was actually larger. So it was larger than itself. But on Tuesday, 4th of November in 2003, this flare absolutely saturated X-ray detectors. And in astronomy, it's worth noting that solar flares are a big part of what we consider sort of space weather. And monitoring the solar flares is of a great deal of concern, not just to the International Space Station, but to all of the satellites we have in orbit. Anybody who wants to go up to the space station or fly around out there, you wouldn't necessarily want to be subjected to the radiation of a solar flare. Direct impacts are pretty rare, thank goodness, but these huge classified, these really strong solar flares, they can create a lot of problems, as Canada well knows. We, had a famous power outage in the 80s, I think it was.
89.
89.
March of 89.
Yeah. I was going to say 80s or 90s, so 89. And since then, people have realized that these can actually affect Earth's power as well. So this particular flare in 2003 was what was called a sort of a coronal mass ejection. So it had this associated coronal mass ejection, which is a huge amount of hyper hot, very active plasma coming out of the sun's surface. It's zipping through the solar system, something like 2,000 kilometers per second. Really high energy stuff. So only part of that was directed towards Earth. So of course, yes, you wouldn't want it to maybe directly hit. We're not quite sure what effect that would have on the atmosphere, but it might not be good. But this one was a glancing blow, but it was a new number 1. So this is an X-ray flare, and it had all kinds of sort of implications for physics and astronomy and space weather monitoring. So this largest flare ever recorded exploded out from the sun's surface, and this huge, intense burst of radiation came streaming towards Earth, and everyone was like, "Yay, aurora!" Well, and then all the astronomers and physicists were like, "Wait, watch out for the satellites." So before the storm peaked, we actually saw X-rays coming in. Of course, high energy X-rays are a type of light, but they can also, cause overloads. And they actually overloaded detectors on some of the satellites which were in orbit. So this is one of the, possible concerns is you can have this radiation coming in that actually causes satellite malfunctions. So I believe this was a geostationary operation of satellites. And that meant that, of course, the scientists had to just take estimates on the size of the flare because they couldn't measure it. Their measuring devices were overloaded, which is that's another way of saying it was, in fact, really, really big. So they had to actually revise the flare's size upwards after it occurred. They've given it this X classification, which just sounds, like it must. Yeah, X files. So this X classification is for the very, very large flares, and it went from merely huge, which was X28, to what has been quoted as whopping at X45. And I had a look. I couldn't find anything over X45 that came close to hitting Earth. Although, us entering a period of more activity for the sun, we might have some more chances. Now that said, this particular flare, it's if it had actually directly impacted Earth, might have done quite a lot of damage to electrical networks. There might have been power outages. This flare, X-ray radiation, was quite substantial, and none of it reached the surface of Earth because, thank goodness, we have a magnetic field and a lovely atmosphere protecting us. So hooray for having a molten core. Good stuff. So it was really, really cool, and it was just at the right time, at the right for Earth, where we had enough knowledge in the physics and space sciences to where we could actually go ahead and estimate what was happening with this particular solar flare. And since then, we've continued to study the sun and solar flares and, use solar measurements to sort of calibrate the response of our estimates for how our atmosphere is going to react to X-rays. So it's been quite good, and it's actually what's used to help a lot of places make sort of adjustments to their power grids. So we're hoping that this plus our previous experiences will mean that Canada does not have any more giant power outages in the event of sort of overload situations. But yes, November 4th, 2003, I was not in Canada at that point, but it does sound like it would have made some pretty good aurora.
Don't remember whether or not that was one of the nights where there was terrific aurora. I was here at York, and I do remember in the early 2000s we did actually see some aurora down here this far south, which is quite rare, but I just don't remember whether or not it was this particular 2003. But I have seen 3 or 4 aurora in 35 years here in Toronto. It's rare to get them this far south.
Indeed, and it is quite an interesting effect because you talk about astronomy, and not everybody realizes just how important a role that space weather plays in astronomy, but also for astronomy radio, because one of the things that happens with this X-class solar flares, they're actually known for, is radio blackouts. So since we're on a radio show right now, I figured that was something in particular relevant to us.
It's something of a golden age of solar astronomy. If you think about it, we've got a number of satellites that are continually monitoring the sun from a variety of space agencies, including 2 probes that are sort of, cruising through the corona and getting up close and personal with the sun. So, we're trying really hard to better understand the star at the center of our solar system, amongst other reasons, because we want to protect ourselves here by having as much advance warning as we can for these sorts of events.
Indeed, and going to places like the International Space Station on a larger scale, or building that lunar gateway and building a base on the moon, this is all going to become much, much more important going forward. So, I believe it's the Parker Solar Probe was the one who diving close to the sun's surface, and
that's the NASA probe. But there is also an ESA probe whose name eludes me just offhand. I want to say
Solar Orbiter.
Oh, it could be. That sounds about right. But the fact that we've got 2 probes simultaneously buzzing the sun just underscores the importance of understanding our star.
Oh yes, and we haven't even gotten into the corona and the magnetic fields. But if we're smart astronomers, we deflect the conversation here and go off to the next topic.
Well, in that case, let me take us to your favorite planet in the solar system, Elena.
Yay!
Mars. Okay. And a tip of the hat to you, Satish, because of course, arguably you should be talking about this one, but I'll take this story for you. November 5, 2013 saw the launch of the Mars Orbital Mission, better known as MOM, or Mangalyaan, unless I've mispronounced that badly, India's first interplanetary probe. Spoiler alert, they're planning MOM-2 to be launched in 2024. Fingers crossed that happens. At any rate, this probe was a representative of the 4th space agency to reach Mars orbit. And for those who are trying to keep track, that's NASA, the Russian Space Federation, as well as the European Space Agency. They were the first 3 groups that put probes into orbit around Mars. India was the 4th. But notably, India did it on their first attempt. Not half bad there, people. Orbital insertion occurred September 24th, 2014. Even better, this probe is still operational. So we're talking about, give or take a bit, 7 years and counting worth of terrific observations of Mars. And for those of you who have sort of, kept half an eye on MOM's activities, they have sent back some very stunning, quite spectacular images. I mean, there's lots of good science they're doing too, but let's face it, we all love images of Mars, and MOM has sent back its share of really great images too. There are 5 instruments on board to study Mars. A run-of-the-mill everyday photometer, a methane measuring sensor. Oh, is methane certainly the hot potato there, trying to figure out what it's up to on Mars, in Mars, around Mars. Oh, dear. No shortage of speculation about methane on Mars. It has an onboard Mars analyzer, so basically it's able to sniff the upper atmosphere and determine atmospheric composition. Thermal imaging spectrometer, as well as that wonderful color camera that I was mentioning to you. So a nice suite of instruments. Perhaps one of the most, I won't say exciting facts about this particular mission is how little it cost. When we talk about Mars missions, when you think back to Viking, when you think back to Pathfinder, Sojourner, any of the Mars exploration rovers, et cetera, you're talking about hundreds of millions of dollars. And in fact, when you start talking about Curiosity as well as Perseverance, you're talking billions of dollars. I'm talking US dollars here. Mangalyaan, MOM, was put together, launched, and is successfully operating around Mars, and it only cost about 73 million US dollars. Let's order 3 or 4 of them, people. Here, I mean, this is cheap at 10 times the price. So, they managed to put together this terrific probe, and there's all sorts of good reasons for that. They applied the KISS principle. Keep it simple. It was very modular. It was very, state-of-the-art instruments. They weren't trying to reinvent the wheel. They were taking off-the-shelf type technology, putting it together in a very sensible fashion. They didn't go out of their way to try and produce something that was that unique. Rather, they stayed with what worked. They kept it simple. They launched it, and 7 years later, the success is still being garnered by the Science Research Council in India. So, a tip of the hat to this very, very successful mission, India's first foray into interplanetary space, and they did it really, really well. MOM launched November 5, 2013.
Indeed, yeah, this was actually one of my favorites as well. It's a great mission, and and as you say, it's gotten such good science, output and such good science return, and it's I can't wait to see what they do with Mom too.
Satish, do you remember much about the original launch? Because you were probably still in India in and around that time.
I was, and I had just begun to leave my job and restart my education at that time. So, and the couple of things that I can probably just mention, not that they're directly related, but the fact that this could happen as a low budget mission is because India, or the Indian Space Research Organization, has had probably 2 decades of experience doing low budget missions and launching satellites in general for all sorts of people or countries. And I'm just saying maybe that's one thing that could enable such a low budget mission.
Mm-hmm.
And then the other thing is, yes, exactly. And then I think I've heard correctly that this entire mission and a couple of others, they didn't actually have any, dedicated astronomers or, highly qualified astronomers as such, or space scientists. All they had were technicians and probably 1 or 2 people who were managing the project. So it was not only low budget, but it was also pretty nicely done with people without any high profile careers as such. So that's what I think I heard.
Well, it sounds as if it was a good recipe. If obviously, success garners a lot of accolades, and whatever the Space Federation did, and it probably was a summation of everything that you have just said, and probably a few other things that we haven't even spoken about. But they did a good job and continue to do a good job. I mean, the longevity of missions, we have often commented on this show about NASA's longevity. And if you think about it, the Russian Space Federation over the decades has not managed to have spacecraft that have stood the test of time. They've had some terrific results, but for both of you sitting here, can you think of any Russian mission into interplanetary space that has spanned decades?
Precisely. Well, not that my word would matter, because
No.
I might miss a few
It does
things,
matter.
but still.
But here we are talking about MOM, 7 years and counting. I can't think of any Russian mission which has, outside of Earth orbit, they've obviously got telecommunication satellites and the like that have been in Earth orbit for long periods of time. But going off to the moon, going off to Venus, going off to Mars, and so on, the longest mission that I can remember is literally the Lunokhod, where they went to the moon and they were active in that foreign environment for, something like 7 or 8 months. The missions to Venus, Venera, when they got there, lasted, unfortunately, only minutes to hours. So having a mission last 7 years and counting, the Indian Space Federation needs to pat themselves on the back. They've done a really good job.
Agreed.
I think they're trying to. Yeah.
When you say that, like, everything that comes to mind is the longest human stays in space records, which I believe are still held by the Russians. But
that's true. That is true.
Outside of humans in space, space missions that have lasted a really, really, really long time, this MOM mission has got to be one of the best.
Yeah,
it's definitely right up there.
Yeah, I mean, when we think about NASA, you think of Voyager and 35 years and counting. The Pioneer missions, they lasted 25 years and then some. Opportunity 14 years on Mars and so on and so forth. Really long lifetimes. And as I say, the European Space Agency has done the same. Their Venus orbiter, their Mars orbiter, the Philae mission, Rosetta. I mean, cruised in space for 9 years before it got around to doing 4 years of terrific science. I mean, these are really, really good numbers. I just don't. You can't attribute that to the Russian Space Federation for automated vehicles. As you say, for humans in space, Mir, the longevity of astronauts on board the International Space Station, et cetera, et cetera. Yep, absolutely. They hold those records. But the automated spacecraft, not so much.
Yeah, and we'll probably wrap that up with a tip to Voyager 2, which is, I think, the longest running.
Yes, I think that's true. But although only by a couple of weeks compared to Voyager 1.
Yeah, that's true. All right. So, Satish, I think moving us sideways a little bit and back to the 1800s, you've got a little more astronomy history for us. Something about the sun is in there somewhere, I think.
It's right here for Harlow Shapley. Again, needs no introduction, but we will still celebrate the birthday. So November 2, 1885 is, excuse me, it was the birthday for Harlow Shapley. He was an American scientist. He was head of the Harvard College Observatory for quite a long time, actually. It says 21 to 52, the 20th century, of course. And he was also a political activist during the latter New Deal and Fair Deal, which I will not get into. But my point is, Shapley used Cepheid variable stars to estimate the size of the Milky Way galaxy and the sun's position within it by using parallax. And in 1953, he proposed his liquid water belt theory. Now we know it better as the concept of a habitable zone for any solar system or a system in general. He's also credited with triggering the onset of extragalactic astronomy, all due to a rather infamous great debate over island universes and spiral nebulae, etc. There's loads of things. This debate was with Heber D. Curtis, and he's also known to have initially been opposed to Edwin Hubble's ideas. And on a different note, was associated with George Hale along with the Mount Wilson Observatory, and then later on with as I mentioned earlier, the Harvard College Observatory replacing Edward Pickering. He also can be, mentioned for hiring Cecilia Payne, who was the first successful doctorate candidate out of the Radcliffe College, which some of us might remember was an all-men's college at Massachusetts. So, I'm not sure what's the word opposite to troublemaker, but he did a lot of things which really shook up the arena. So happy birthday.
Certainly the great debate there with Curtis in 1920 stands out to me. In fact, the CASCA conference, the Canadian Astronomical Society conference last year, which Elena and I were part of the local organizing committee, was meant to celebrate that 100th anniversary of that really rather important debate. It really wasn't a debate. It was just, a couple of astronomers, putting forward viewpoints about the structure of the universe, not really a knockdown, drag 'em out debate. But nonetheless, it was a really important moment in history. We were still trying to coin the term galaxy and whether or not we really did live in island universes or not. It really was an important moment in astronomy history between Curtis and Harlow. But he had an interesting history, and certainly when you think about him inheriting the position or becoming the director of the Harvard College Observatory, that really did put together a lot of fabulous science, particularly spectroscopy and the understanding of the universe and the nature of stars within it in the early part of the 20th century. Really exciting times, and he was right in the thick of it.
Indeed, and this was all around the same time. Of course, his student being Cecilia Payne-Gaspard, they were realizing that stars were in fact made of hydrogen and helium, which is something we now take for granted.
Yeah, that's
So
right.
in addition to realizing that, the Milky Way galaxy is, what we now call a galaxy, one of many,
Yeah.
there's huge groundbreaking sort of shifts in our perspective happening around that time.
Hard to think that the word galaxy wasn't in the astronomer's lexicon back in 1920.
It goes to show you just how much has changed over, just a mere few hundred years. It's ridiculous.
Quite true. Quite true.
Well, I think we have time for probably one more this week in history. So I'll just go and hop over to November 3rd, 1973. NASA launched Mariner 10, which is always a fun mission to talk about. So I figured this was a good chance. Mariner 10 was launched at 1973. So we've been a bit eclectic, hopping around with our dates. So this is the 1900s. I'll just place us here. This really fun spacecraft was the first to explore Mercury and take close range pictures of the planet. So Mercury was, largely unexplored. It was quite a mysterious object for most of human history, really. Mariner 10 was the first to really, get those close range pictures so that we could see the cratering and the structure on the surface. And it was also, I believe, the first spacecraft to use this sort of gravitational pull of one planet to reach another. In this case, it was Venus going off towards Mercury, and it did. I think this sort of flyby attempt, gravitational slingshot. You can actually get some speed doing this, and use it to change your trajectory as well. So it's a really, really popular technique. This gravity assist sort of launching. So it was actually kind of a doubly interesting mission, if you can call it that. And this robotic probe was, not maybe the longest lived, so it can't make any sort of claims to fame on longevity. It was under 2 years. I think the whole mission was a year and 4 months or so. But its objectives were to measure Mercury's environment. Of course, Mercury being the closest planet to the sun, could it have an atmosphere? What would its surface be like? This was all questions that were sort of to be answered. This Mariner 10 was the first one to really give it a good try. So it came out there, and I'm not sure exactly how long it took to get into Mercury. I don't remember. It wasn't too long, but its navigational system kept it on track to Venus and then out to Mercury. But this was in the 70s, so they were still using some pretty what we would consider old technology. They actually had a television photography system on Mariner 10, which I thought was really fun, because this was something that was used before we had sort of the modern cameras and digital transmission. This television photography experiment that was on the spacecraft had little sort of tubes where there could be sort of imaging passed through, and this whole system became greatly imperiled by getting too close, getting too hot when the cameras failed to turn on after launch. And to avoid the sun's damaging heat, I believe they sort of put the cameras on the side facing away from the sun. So they had to heat up the cameras to prevent them from getting too cold from space. So it was this whole, sort of precarious situation, really, launching something that close to the sun. But they did manage to do it, and the test photos, showed that it was okay, and they were actually able to return about, I think, 7,000 photographs of Mercury and Venus for Mariner 10 flybys. So that's not too shabby for a initial mission.
You're right. The Mariner 10 mission barely lasted 18 months, but boy, what a phenomenal 18 months. I mean, 3 flybys of Mercury and just to toss in a quick flyby of Venus just for the heck of it. And for literally 30 years, it was our Bible as far as Mercury was concerned. We didn't know anything really more about Mercury until we got around to Messenger in 2008. So from 75 to 2008, Mariner 10 remained the only probe that did any decent surveillance of Mercury. And, it did it ever so well for relatively rudimentary technology there in sort of the mid-1970s. So, very, very much a hats off, tip of the hat to the Mariner 10 mission.
Absolutely. And it just goes to show, if you can think of how much we've gained from Mercury with our newer mission, how much more does that make you want to go back to Neptune and Uranus? I was like, yes. More missions.
Well, I agree. An orbiter around Uranus keeps being spoken about. I still haven't seen any definitive, plan, but they still keep talking. So hopefully Uranus and, as you say, Neptune, that would be really good to round out the 8 planets of our solar system.
Yeah, I think we need to get the mom folks involved on this. They could make it happen.
They could indeed.
All right, folks. I think I should probably take a second to remind you, as we're slightly over half the broadcast, that you are in fact listening to York Universe, broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you would like to find out more information about our broadcast, you can always head over to observatory.info.yorku.ca. If you'd like to go ahead and check out the OPV, which is running at the same time, you can also go to that same website, or you can go to York U Observatory on YouTube and join the live chat. For questions, content on Twitter, you can find us at York Universe. And tonight you are listening to Elena, Paul, and Satish, and we're currently discussing space missions and all kinds of things. So we have on our way to, on our way to the news, we have a few important updates. So I think, Paul, you were going to give the ISS update, weren't you?
I am indeed. For those of you who had your alarm clock set for an early morning launch of Crew 3 to the International Space Station, it was going to fly tomorrow morning. Turn off the alarm. There has been a small little incident, a medical incident of some description, that has grounded the crew until no earlier than Saturday evening, November 6th. Doesn't sound as if it's serious. NASA is being pretty tight-lipped about what has actually happened, but obviously one of the 4 crew members has had some sort of incident that is of a medical nature, and out of, I'm sure, an abundance of caution, they have deferred the launch until late Saturday evening. At the moment, no earlier than 11:36 p.m. Eastern Time on Saturday, November 6th. So, as I said, turn off the alarm for tomorrow morning. It ain't going to happen. The 4 astronauts who are launching, Raja Shari, Tom Mashburn, Kayla Barron, they are all NASA astronauts, and then the ESA astronaut on board, Matthias Maurer. So fingers crossed that they can get to the International Space Station on Saturday. Crew 2 is supposed to return. Well, they're not going to return now on Thursday. So they will be returning presumably sometime next week. So a little bit of a reshuffle of the International Space Station's crew agenda, but nothing too serious, it appears.
Well, I hope it isn't serious. I'll go ahead and add to our little update news items. We have, of course, as most of you know by now, we are continuing our weekly Teletube broadcast on YouTube every Wednesday at 7:30. However, every first Wednesday of the month, you can now sign up for in-person tours. That's right, socially distanced, but they are happening. So if you would like to sign up and get a ticket, you can go to observatory.info.yorku.ca. Our first tour of November is, of course, this week, because it is the first week of November, as mentioned before, which none of us can believe because, oh my gosh, November.
Exams.
What happened? Anyways, here we are in November, and we are running a live tour this Wednesday, of course, weather allowing, and every other Wednesday will still be our Teletube broadcasts. Of course, on Mondays, we'll keep up with our OPVs, and that's basically all the news that's fit to print now until, of course, our 2022 calendars come for sale. So watch out for that as well. Now, speaking of news, let's get back to some more astronomical news, shall we? There's a little bit of a related article to a bit of history. Paul, we're talking about solar flares.
We are indeed. Following up on that big flare that you were commenting on from 2003, there was, not an X45 flare, but an X1 flare occurred last Wednesday, 27th, Thursday, the 28th. It was a rather large, energetic solar flare. We are on our way towards solar maximum. It's been a bit of a quiet sun. For those of you who watch sunspot counts, for example, spaceweather.com or other sites out there, most of 2021 was a bit of a dead loss as far as looking at the sun and sunspots were concerned. Very few spots in the early part of the year began to pick up towards the latter part of the year, and this year it has carried on building. So there are a few spots. Well, one of those spots, by the name of AR2887, decided to launch unpremeditated a solar flare last Wednesday or Thursday. As I said, it was a pretty energetic one, rippled through the sun's atmosphere and launched a coronal mass ejection, so an event of significant radiation more or less towards the Earth. So in this particular instance, this is sort of one of those perfect storm type arrangements. It's one thing to have a solar flare. It's another to have a coronal mass ejection that comes from that solar flare, and will it be pointed towards the Earth? Because coronal mass ejections can come from almost any part of the solar surface, and of course, not all parts of the solar surface are facing the Earth at any given moment in time. Well, this one was aimed towards us, although not square straight on, but nonetheless a glancing blow from the coronal mass ejection, this wave, this particulate wave of radiation, primarily protons and electrons, but with some heavier elements, aimed towards the Earth, began to wash over our planet Saturday evening this past weekend, most of it happening on Sunday. This generates what we call a geomagnetic storm. So these charged particles interact with the Earth's magnetic field. 3 cheers, as we said earlier, for the Earth's magnetic field, because it manages to deflect a significant amount of this charged particles, meaning, of course, that you and I don't get peppered with high-speed charged particles. This is a good thing. Nonetheless, a coronal mass ejection moving at a couple of thousand kilometers a second, that's why it took the better part of 48 to 72 hours to get to us, they can overwhelm the magnetic field. And these charged particles can be funneled along the lines of magnetic force into the north and south magnetic poles of our planet. Well, on the way through, the outer regions of the Earth's environment, these charged particles can, of course, interact, aka slam into, satellites. And this can be rather damaging. So depending upon the amount of particulate radiation, the speed with which they are moving, therefore the energy that they have, you can do satellite damage. And if you're an astronaut on board the International Space Station, then again your radiation dose goes up. So all of these things are not cool. The cool part is the aurora, okay? If you happen to be in a dark site at high northerly latitudes or, very high southerly latitudes, like I'm meaning 60 to 70 degrees north or south latitudes, then the possibility of seeing aurora is really quite high. And there were hopes that this coronal mass ejection causing this geomagnetic storm over the weekend was going to generate auroral activity at lower latitudes, aka southern Canada. Okay, didn't happen. Okay, sorry about that. I have seen some pretty spectacular images of aurora this past weekend, but most of them were at much higher northerly latitudes and much higher southerly latitudes. So southern New Zealand, northern Labrador, Lapland, and so on. Unfortunately, the geomagnetic storm did not swing far enough south for those of us in southern Canada, northern US, to be able to see any significant auroral activity. That's bad news. There has been a little bit of paranoia in the media. That is to say, this coronal mass ejection. It was an X1 flare, but as Elena said, nothing like the X45 flare in 2003. But an X1 flare does carry a bit of a punch. And of course, people trotted out the Hydro-Quebec disaster of March 1989, where they spoke about the Carrington event of 1859, where telegraph wires started arcing and sparking and setting off fires in telegraph stations because of, again, a coronal mass ejection. There's no doubt that you can induce significant electric currents on the surface of the Earth, which can be very damaging to electronic equipment and, of course, our satellite entourage around us. But the X1 flare from last week, and by the way, AR2887 burped again yesterday, this time an M1 flare, so this is much lower in overall radiation output. But nonetheless, it's washing towards the Earth. We can expect another geomagnetic storm November 3, November 4, but given the fact that we didn't see a whole lot of action this past weekend from an X1 flare, nobody is getting too excited about the M1 flare. The point being here, though, that coronal mass ejections are still relatively unpredictable. We know that there are more of them at the height of solar maximum, and we're heading towards solar maximum, but we still can't predict where they will occur on the sun's surface, and therefore whether or not they are going to be aimed towards the Earth and at what level of energy we are talking about. But it does behoove us to continue our monitoring of the sun's environment, the Solar Dynamic Observatory, SOHO, the Parker Probe, and so on, to give us greater insight and at least to give us forewarning of when these coronal mass ejections actually occur. Because we see the light signature, visible light signature, within 8 minutes of the flare. It's the radiation wave that follows it at a much slower pace, 24 to 48 hours at the earliest, perhaps as much as 72 hours later. So, at any rate, bottom line to all of this, folks, is that coronal mass ejection from last week has washed over the Earth with not a whole lot of excitement, but the show's not over yet. There will be another one later this week, but only those folks in very far northerly latitudes are likely to see the aurora.
Indeed, and as you say, it is just an X1. So,
yes, just the next one. Exactly.
And it was worth it going. It says X is the highest class, M is below X, and I believe C is below M, right?
Yes. Yeah. Figure. I have no idea how they figured those.
So again, not in alphabetical order whatsoever. CMX. I suppose it kind of is, but again, another astronomical scale. But it is worth noting as well, is one of the things you can do if you are forewarned is to move your spacecraft to the other side of Earth. So it's not on the side that gets hit.
Not easy to do in geostationary orbit, really.
No, but if you have thrusters, this is something to think about. If you're going to design the next International Space Station or a space hotel, you might want to plan ahead and put in some thrusters. So I'm not sure we have time for another article to date. Satish, you've got the next one. Do you want to save it for next time, or you think you can do a real short version? Or shall we continue talking about sunspots?
I think we should continue talking about sunspots and sun flares or whatever, the variety of things is.
There's so much to talk about too, because of course, we've seen from our sun that it can go up to X45, as far as we know, right? That is still the strongest that we have seen
in recorded history. Yes,
in recorded history, and that was again a glancing blow. But in theory, we could have even higher solar flares. If you hear in the news somebody saying a really strong solar flare and they're not talking X45, maybe just take it with a couple grains of salt. But I absolutely agree with you that it was really too bad that we couldn't have had some nice, strong northern lights during Halloween. That would have been something.
Timing would
Well,
have
it doesn't
been
matter to talk about, like, it says it's the 25th solar cycle. I'm just wondering, when did we start counting the solar cycles? If it's 11 years, so
25
how do
times
we
11. So the
Yes.
18th century is the answer to your question, is when we started counting sunspot activity and the realization that they were in cycles of 11 years. So cycle number one, I think you'll find, was the early 18th century.
Okay, well, that may become a birthday shout out for someday.
Yes, yeah. Actually, it'd be rather an interesting sort of trivia fact to find out when day one of cycle one for sunspot activity was measured, because I'm sure it's retrospective.
Precisely.
Oh, yeah. Well, and you also have records going back before that, which were less accurate. So it would be quite interesting to see if you could get it to match up.
You need to sign us off.
Unfortunately, we're not going to do that tonight. So we will have to say goodbye to everybody and just remind you, you are listening to York Universe, broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. For chat, questions, or content, you can find us on Twitter and Instagram at York Universe. And tonight you're listening to Elena, Satish, and Paul. We're discussing the sun, and if you would like to catch the last seconds, you can still catch the OPV at observatory.info.yorku.ca. Thanks for coming along, everyone, and it is great to have a good night.
Good night.
More of our
Good
AFM
night.
original programs on our website. It's really easy to find.